Okay, this is a review of production inputs, okay? And production inputs follows a similar logic to the utility discussion that we spoke about. The only difference is that under the utility topic, we were talking about individuals purchasing units of a good. With production inputs, we're talking about firms or companies purchasing workers and machines. Okay, so if you remember from the discussion about utility, we said you keep buying stuff. Let's say you're talking about apples. You keep buying apples as long as the marginal utility is greater than or equal to the price of the apple, right? The additional benefit you get is greater than or equal to the price of the apple. And we said that if you're choosing between apples and oranges, you would compare the value you get from apples with the value you get from oranges. Okay, and ideally you would want, this is apples, this is oranges. The last apple you got gives you the same amount of additional value as the last orange that you purchased. Here we're talking about firms buying workers and machines. So we're going to talk about the additional benefit you get from each worker, the additional benefit you get from each machine. The only difference is that when it comes to workers and machines, we're going to talk about total product. Total product is how much you're able to produce, which is Q, right? So we're going to say Q, what you're going to produce, is some kind of a function of labor and capital, okay? That there's some kind of a production function where you put in X number of workers, you put in a certain amount of machines, and out pops the amount of product, Q, okay? So let's say that I tell you that labor, okay, total product, or Q, total product, okay? With 0 workers, you have 0 total product. With 1 worker, you have 10 more units produced. With 2 workers, you have 16 units produced. With 3 workers, you have 18 units produced. So then we could talk about the marginal product of labor, okay? How much the first worker produced. Marginal product of labor is the change in total product divided by the change in workers. Here, since we're jumping from, over 1 worker at a time, so we don't worry about the downstairs, but the first worker added 10 units of product. The second worker added 6. The third worker added 2. So you have here, holding constant the amount of machines in the production process, we have diminishing marginal product of labor, okay? Again, holding constant the amount of machines in the process. And if you hold the number of workers constant, you're going to have diminishing marginal product of capital, okay? So the first worker, you're able to get 10 units of product out of him. The second one, 6 units of product. The third one, 2 units of product, okay? So this gets us closer to this idea of how much do you benefit? What do you get out of each worker? The only thing is that if you're going to compare how much you're getting out of each worker with how much the worker costs you, the worker costs you something that is a dollar number. Here, I have 10 units. Maybe you're making t-shirts. I'm getting 10 t-shirts out of the first worker, 6 t-shirts out of the second, 2 t-shirts out of the third. So we have to convert these numbers to dollars. So what we do is we multiply the marginal product of labor with the price of the product, how much you can sell the t-shirts for, and this is how much additional benefit I get from a worker, okay? And I'm going to compare that to the cost of the worker, which is the wage. Okay, so the rule is going to be just like when you're choosing how many apples to buy, you're going to compare the additional happiness you get from the apple with the cost of the apple. Here, when I'm deciding how many workers to hire, I'm going to compare the benefit I get from the worker, which is how many t-shirts that worker produces, times the value of each t-shirt, with the cost of the worker, which is the wage. Okay, and so we can rewrite these equations as marginal product of labor times the price, greater than or equal to the wage. If I'm deciding how many machines, marginal product of capital times the price of each t-shirt compared to the rental rate of the machine. That's the cost of the machine. Okay? And if I'm deciding how many workers relative to how many machines, I'm going to buy workers and machines such that the ratio of marginal product of labor times price, which is the value of marginal product, okay, to the wage, with the value of marginal product of capital to the rental rate. Okay, so these are exact mirror image of the conditions we have in utility, but we're applying it to the case where we're buying workers and machines. And by the way, just like in the case of utility, we said as you consume more and more apples, let's say, you're getting a higher and higher utility. It's just that the rate of increase of utility is smaller and smaller. At some point, you might reach a top, that would be where marginal utility is 0, and then you might actually go negative. Okay, so the marginal utility is getting smaller and smaller, it gets to 0, and then it might even go negative. So this would be total utility. So here with workers, as you add more and more workers, okay, total product is increasing, 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 but it's increasing at a decreasing rate. So the marginal product is decreasing, okay? And similar for if you do the same thing for capital, okay? Okay, so let's apply these concepts to a quiz that practices these concepts. Okay, hold on a sec. Production inputs. Okay, a firm produces truffles by using labor and capital. The price of labor is $10 a unit and the price of capital is $20 a unit. At the current output level, the marginal product of labor is 40 truffles and the marginal product of capital is 60 truffles. Okay, so we can tell from here whether you are maximizing. To reduce the total cost of producing the current quantity of truffles, how should the firm change its spending on labor and capital? All right, let's write down the numbers. So basically, labor is 10, capital is 20. Marginal product of labor is 40. Marginal product of capital is 60. 10, 20, 40, 60. Okay, so we have 10, 20, 40, 60. Marginal product of labor times the price divided by the wage has to be equal, if you're maximizing, to marginal product of capital divided by the rental rate. Okay, so we're told, so we're trying to figure out if it is equal actually, right? Okay, price of labor is 10, price of capital is 20, marginal product of labor is 40, marginal product of capital is 60. We're missing the price, but realize, by the way, since price goes into both, so I can actually ignore the price. I can just compare marginal product relative to rental rate, marginal product relative to the wage, okay? And in our particular case, so 40 divided by 10 is 4, 60 divided by 2 is 3. So you see that the value you're getting from the last worker is actually, in this case, greater than the value you're getting out of each machine. So if you want to improve how you're doing your production process and reduce your costs, you should reduce how many machines and increase how many workers, because the workers give you more value. So they should hire more workers and use fewer machines. So in this case, you would increase labor, capital decrease. The answer would be E. Labor increase, capital decrease. Okay? The table above shows the short-run production function for picking apples based on the production data. Which of the following statements about the marginal product of the fifth worker is true? So the fifth worker, the marginal product, you go from 20 to 24 in total product. That means the fifth worker adds 4 units to production. Okay? It is the maximum that can be attained. Is that true? Is the marginal product of the fifth worker the highest marginal product? Well, let's see. The marginal product of the first worker is 4. The second, it's 5. The third, it's 6. The fourth, it's 5. And the fifth is 4. So the marginal product of the fifth worker is certainly not the highest. In fact, marginal product is highest for the third worker because the third worker gets you a marginal product of 6. Okay? It's greater than the combined marginal products of all the other workers? No. It's greater than the marginal product of the first worker. Well, the first worker gives you a marginal product of 4, which is the same as the marginal product of the fifth, so that's not true. It's less than the marginal product of the third worker due to diminishing returns. The third worker gives you a marginal product of 6. The fifth worker gives you a marginal product of 4, which is less because of diminishing returns. That is correct. So the answer is this one. Okay? Next. Assume that both the product and labor markets are perfectly competitive. It would be profitable for a firm to hire additional labor if the ratio of the wage to the marginal product of labor is what? So here we're only talking about labor. We're not talking about capital. And we said if you're only talking about labor, you want to make sure that the rule would be, right? Hold on a second. The rule would be that you're going to hire as long as price times marginal product of labor is greater than or equal to the cost, right? So let's take a look. Let's rewrite that, right? We want the price times the marginal product of labor to be greater than or equal to the wage. Okay, so let's see what it's asking here. Here it's saying it would be profitable for a firm to hire additional labor. If it's profitable, that means it's greater, not equal, right? Greater, right? Because that means the additional benefit is greater than the cost. If the ratio of the wage to the marginal product of labor, so they're reworking this equation, they're bringing the marginal product of labor over here. If we divide both sides by the marginal product of labor, okay, so then we have price is greater than the wage divided by the marginal product of labor, right? Remember, you can, when you have an inequality, you can treat it just like an equal sign. It's just that whenever you're dividing by a positive number, it stays the same. But if you're dividing by a negative number, you have to flip the inequality. In this case, the marginal product of labor is positive. So another way of writing this condition is this way, that the ratio of the wage to the marginal product of labor is less than the price. Okay? So it should be less than the output price. There you go. Okay? By the way, okay, that's fine. Okay. The table shows the short-run production function of a perfectly competitive firm that produces potatoes using one variable input, labor. After which worker does diminishing marginal product first occur? Let's see. The first worker adds 3 potatoes. The second worker, 4 potatoes. So the marginal product has actually increased. The third worker, 3 potatoes. So after the second worker, you went from 4 potatoes to 3 potatoes. That's when diminishing marginal product set in with the third worker, okay, which is after the second worker, okay? The table shows the short-run production function of a perfectly competitive firm that produces potatoes with one variable input, labor. If the firm can sell as many potatoes as it wants for $2 a pound and has to pay each worker $5 an hour, how many workers should the firm employ to maximize profits? So we're told the price is 2, the wage is 5, so the rule is price times marginal product of labor has to equal or be greater than or equal to the cost of the worker, which is 5, right? So let's actually calculate the marginal product, right? The first worker produces 3 potatoes. Each one you can sell for $2, so 3 times 2 is 6. So the first worker, you're making $6 off of him. He costs you 5. Yes, you hire that first worker. The second worker produces 4 potatoes, $2 each, that's $8 worth. He costs you 5, yes, you hire the second worker. The third worker makes 3 potatoes, 3 times 2 is 6. He costs you $5, yes, you hire the third guy. The fourth guy, you get 2 potatoes out of him. 2 times 2 is 4. 4 is less than the cost of the worker, which is 5. So you do not hire the fourth worker. You stop at 3 workers. Okay? So you hire 3 workers. A perfectly competitive firm is currently producing at the profit maximizing output level. If the marginal physical product of labor, that's the same thing as the marginal product of labor, is 10 units an hour, and the firm pays a wage rate of $8 an hour, which must be true. If it's profit maximizing, that means it's following the condition that price times marginal product of labor is equal to the wage. Okay? The wage is 8. Okay? If the marginal physical product is 10, so 10 times what equals to 8? 80 cents an hour, okay? So it must be, right, the price of the item is 80 cents an hour. 80 cents a unit, because 80 cents a unit times 10 units gives you $8, which is how much you're paying the workers. The output price is 80 cents a unit. Last question. Given the information above, which of the following is true for a firm buying its labor and capital inputs in a perfectly competitive market? So what's the rules? Here you're being told marginal product of labor is $2.50, price of labor is $50, marginal product of capital is $7.50, price of capital is $100 per unit. So let's see. We have to set marginal product divided by cost equal across the two, right? Marginal product of labor is $2.50 divided by 50. 250 divided by 50 is 5. Okay? 750 divided by 100 is 7.5. So it looks like capital gives you more value than labor, so you should hire more capital and fewer workers. Okay? So the firm is currently producing its current level of output with the least cost combination. No, it could do better by hiring fewer workers and switching to machines. The firm's level of output will remain the same if 1 unit of capital is substituted for 2 units of labor. We don't even have enough information to be able to tell that. The firm can reduce the cost of its current level of output by laying off workers and employing more capital. That's the answer. Okay, I hope you find that helpful. So again, remember, the rule is if you're looking to figure out how many workers, you set the marginal product of labor or the marginal physical product of labor times the price of the output to be greater than or equal to the wage. If you're only deciding how many machines, price times marginal product of capital has to be greater than or equal to the rental rate, which is the cost of the machine. And if you're choosing between machines and workers, if you are maximizing, and that means you're minimizing your cost of production, it must be the marginal product of labor divided by the wage has to be equal to the marginal product of capital divided by the rental rate. These are the rules, and they are very similar to the rules for utility.